All right, welcome. 1.6 is the next section. We're going to talk about combining functions. Okay, so first way to combine functions is just the normal algebraic combinations. Okay, so those are basically you can add, subtract, multiply, divide. Okay, now the only thing you have to watch out for is the domain issues. Okay, so the domain of the result, okay, should take into consideration the domain of the constituents, it's actually the domain, the intersection of the domains. But that really doesn't tell you much because you're going to actually combine the things you throw out or union the things you throw out. That tells you more. And when you're dividing, say you take f of x divided by g of x is not allowed to equal 0. Okay, so let's do a couple examples. Let's take f of x equals x squared over x plus 5, and g of x equals 2x over x squared minus 25. Okay, so let's take and we're going to add, subtract, multiply, and divide. So, first thing we're going to take, let's take f of x plus g of x. Okay, so we're going to have x squared over x plus 5. Let me move this down a little bit. Okay, plus 2x over x squared minus 25. Okay, so now what you may remember is the difference of squares. X squared minus 25 is in fact x plus 5 times x minus 5. So our common denominator when we have to add these fractions is that x plus 5, x minus 5. Okay, now here we have the common denominator. On g of x, we have the common denominator. So we don't have to do anything there. Okay, but on f of x, we're missing the x minus 5 term. So we will multiply on the numerator and denominator of f of x by x minus 5. So x squared times x minus 5 over x plus 5, x minus 5 plus 2x, and I'm going to write that as x squared minus 25. Doesn't really change, okay, they're the same thing. Now, since I have the same denominators, I can just add the numerators. All right. So I'm going to get x cubed minus 5x squared plus 2x over x squared minus 25. Okay, so that's f of x plus g of x. And I should consider the domain. Nothing crazy going on here, but we are going to throw out plus or minus 5. Okay, so in interval notation, that's negative infinity to negative 5, together with negative 5 to 5, together with 5 to infinity. Okay, let me move that over just a little bit here. Move it over here, actually. Okay, so that's the expression for f of x plus g of x with the domain. Let me just see how much space I've got here. Okay. Now we're going to do f of x minus g of x. So one of the nice things I like about never mind, I guess I can't do that. I'll have to figure out how to do that. I was just going to copy and paste it. I thought I had that figured out, but apparently not. So let's take f of x minus g of x. Okay, same f and same g. So that's going to be x squared over x plus 5 minus 2x over x squared minus 25. And this one doesn't really change too much. Okay. Same thing, we're going to take a common denominator of x squared minus 25. So x squared times x minus 5 over, now I'm just going to write it as x squared minus 25 minus 2x over x squared minus 25. Hasn't really changed much. X cubed minus 5x squared, now minus 2x over x squared minus 25. And we're going to have the same domain. So that last interval looks ugly. All right. So nothing so crazy yet. All right, let's take a look at multiplication. Multiplication, we have f of x times g of x. Again, it's still going to be pretty straightforward. X squared over x plus 5 times 2x over x squared minus 25. And that's just going to be 2x cubed over, I'm going to write this as x plus 5 squared times x minus 5. Okay, and that's because, as we know, this x squared minus 25 is x plus 5 times x minus 5. Okay, and again, the domain's the same thing. I thought I had this. I know I had it. Let me see if I can try again. So copy, Nope. Ah, I had this before. I don't know why it's not working for me now. Paste. There we go. Okay. All right. Now, of course, division is the, no offense if you're the redheaded stepchild, but it is the redheaded stepchild of this situation. Okay. Maybe kids don't even know that expression anymore, but it's the different one. Okay. So f of x divided by g of x is going to be here x squared over x plus 5. Now, I like this old school division sign, but when I do that, I have to remember I have to flip the denominator and multiply. Okay, I had to flip the denominator and multiply. Now let me just write this out. X squared minus 5 is x plus 5 times x minus 5. And then I have here x plus 5 over 2x. Okay, so I'm going to get a lot of simplification here. Okay, this x plus 5 here is going to cancel with this x plus 5 here. One of the x's here is going to cancel with this x here. So I'm going to get x times x minus 5 over 2. Okay, so far looks okay, but now the domain. The domain is where we have to keep our wits about us, all right? So we had to look at the domain of the original expressions. So both 5 and negative 5 have to be thrown out. Okay. But also, we have to throw out x equals 0. Okay, and why is that? Because g of x is not allowed to equal to 0 either. The denominator is not allowed to equal 0. So if you had x equaling 0, that would make this term 0. Also, you might notice that you had the 0 down there. Even though you canceled it, okay, it still kind of has to hang around. Okay, so our domain, and when we put it in interval notation, is going to be negative infinity to negative 5 together with negative 5 to 0 together with 0 to 5 together with 5 to infinity. So what this all means is we're basically taking the whole real number line and we're throwing out negative 5, 0, and 5. Okay? All right, I'll see you guys in the next video.